We finish section 6 by looking at some equations that are in kind of the quadratic form, but notice I've written not with an x but with a u. A to the second power plus bu plus c equals 0. Looks very much like the quadratic standard form, one variable, but we're going to let u represent some algebraic expression. It's not going to be the only variable. So what we're going to do is we're going to look at some examples, but first we're going to practice determining, by looking at these types of problems, what you would represent. Now, the reason that we use u is because it happens to be the variable of choice in calculus when you're doing u substitutions, so we might as well be consistent with it. Plus the fact, in this case, as we're looking through this and we're trying to determine what the u would be equal to, and I think you can see that this is au squared minus 3 times u minus 1, we can say u is 5x plus 6. How often do you get to say u is? So in this problem, 5x plus 6 is that algebraic expression. Now here, do you notice what we have? We have the variable x, but we don't have x squared and x to the first. We have x to the fourth and x to the second. So this is a little bit like 6x squared squared minus 5 times x squared to the first plus 1 equals 0. U is x squared. Down here, I also have the variable x, but raised to a power, and it's but the first term is x to the 4 thirds. The second one is x to the 2 thirds. This still has that look because x to the 4 thirds is x to the 2 thirds squared plus 3 times x to the 2 thirds to the first plus our constant term equals 0. So u is x to the 2 thirds. So once we are able to identify that we can make our substitution, get something that hopefully factors for us, or a quadratic formula, and then we can always go back and plug in at the end. So I've got a couple of examples here that I want us to solve. You can see this one is kind of like the first example here, where the expression is a binomial. So I'm going to say that in this problem, you can see this binomial squared, this binomial to the first. My u is x squared minus 6. So I make the substitution. I write this as u to the second power plus 33 times u plus 62 is equal to 0. Now, if I'm really lucky, this thing will factor. And if not, then I'm going to have to use the quadratic formula. But I got lucky, this one is going to factor. This is going to be a u and a u, which is one of the reasons why we do this. And it looks like 31 times 2 is going to give me that 33, so plus 31 and plus 2. Once we have it to this point, we use the zero product property. U plus 31 equals 0, or u plus 2 equals 0. I'm going to subtract 31 from both sides here. Solve this little linear. I get u is equal to negative 31. Then over here, I'm going to subtract 2 from both sides. And I have u is equal to, looks like, oops, negative 2. Now it looks like you're done because you have u equals and u equals. But remember, we didn't start with the variable u in the original problem. We don't want to finish, have our answer in terms of the variable u. We have to go back and we have to plug it back in. So if you don't start with u, you don't want to finish with u. Sounds like your dad when they get mad at you. I'm not finished with u yet. So what I'm going to do here is I'm going to plug back in my expression for u, x squared minus 6 here. I have x squared minus 6. In for u equals negative 31. Over here, I plug it in, I have x squared minus 6 is equal to negative 2. It's a bad negative 2, but that's what it is. I'm going to add a negative 6 to both sides, or add a positive 6 to both sides, excuse me. And I have x squared is equal to negative 25. Well, it's time to use the square root property. And of course, now we should be able to look at the square root of negative 25 and recognize that as 5i. So x is equal to plus or minus 5i. Over here, I'm going to add 6 to both sides. And I have x squared is equal to 4. And if I take the square root of both sides, even more conveniently, I get the absolute value of x is equal to 2. I have x is equal to plus or minus 2. I have 4 solutions here in my solution set. And because I'm just going to write them conveniently, I'll just write them out as plus or minus 5i, plus or minus 2. Now if you're thinking it's a quadratic, how can you have 4 answers? Well, it's really not a quadratic. Look, This expression is going to be raised to the second power. This is a quartic. You're going to have as many as 4 answers, 4 distinct answers. So there they are. Now over here, this one's a little bit different because it's not already set equal to 0. So that's the first thing I'm going to do. I'm going to add 7t to the 1/3 power to both sides. And I'm going to subtract 15 from both sides. Let's see, and I'm going to add 7t to the 1/3 and subtract 15. There it is. And I end up with 2t to the 2/3 plus 7t to the 1/3 minus 15 is equal to 0. Well, I think very similar to what I had here in this example. I'm thinking t to the 2/3 can be thought of as t to the 1/3 squared. There we go. So I'm going to let u equal t to the 1/3. And I'm going to make my substitution. So I'm going to have 2u to the second power plus 7u minus 15 is equal to 0. So once again, I'm at a point here where I'm hoping it will factor. And again, if it doesn't, it's much messier. You have to use the quadratic formula. And I believe this one does factor as well. So let's see, a 2u and a u, probably a 5 and a 3. That looks like a plus 5 here, a minus 3 here will do it. So now I'm going to set each one of these equal to 0. 2u minus 3 equals 0, or u plus 5 is equal to 0. I'm going to solve each one of these. I'm going to add 3, and then I'm going to divide by 2. I'm a little lazy, so I'll just write it like this. Here I'm going to subtract 5 from both sides. I'll go ahead and match it up so that it balances out height-wise. And I have u is equal to negative 5. Now, once again, don't stop at this point. You're close, but you're not done yet because we're not solving for u, we're solving for t. So I make the substitution back in. I write this as t to the 1/3 is equal to 3/2. T to the 1/3 is equal to negative 5. Well, we solved equations where we had a rational exponent. We just raised both sides to the power. That's the reciprocal of this rational exponent. So we're going to cube both sides. So I have t to the 1/3 cubed equals 3/2 cubed. I'm going to have to do something very similar over here. Cube both sides. T to the 1/3 to the 3rd, power to a power, you multiply, that's going to be 1. So I have t equals 3/2 times 3/2 times 3/2, which is 27/8. Over here, this is t equals negative 5 times negative 5 times negative 5 is negative 125. So my solution set is negative 125 and 27/8. Leave 27/8. I mean, if you want to write it as 3 3/8, that's fine. You don't have to change everything to a decimal and get your calculator out. It's okay to have an improper fraction as long as it is reduced.